the chain rule. And this is probably one of the most important rules for taking derivatives that you're going to have in this class. Probably the most important rule for taking derivatives in this class. Okay, so the idea is if you have a function, a composition of functions, then the derivative of that composition is equal to, is done according to this formula. Okay, so for example, let's suppose that we have capital F of x could be something like sine of 2x to the third power, like that. Okay, so that's a composition of, if we let f of x be sine x and g of x be 2x cubed, then that means that this function here is a composition of f of g of x. Okay, now one way to think about this is that the g of x, let me do it in a different color, is that the g of x is the inner function. And so then that case, this would be inner. And the f of x is the outer function. Okay, so that's outer. And you can kind of see that the sign is on out, and then the inner is like inside. It's usually inside parentheses, not always. Okay, it just depends. But it's a expression that another function is just acting on that whole expression. Okay, so that's the inner function. Okay, so according to this, the derivative f prime of x is going to be the derivative of the outer function. So if we just take this derivative of just the sine x, we get cosine x. Okay. So the derivative of the outer function, but the formula says evaluate that at the inner function. Okay, so this 2x cubed stays untouched. So it remains the same. Okay, so this part right here is this one, and then multiplied by g prime of x times the derivative of this. Okay, so to take the derivative here, you pull the 3 down. 3 times 2 is 6, and then you multiply, and then you reduce this by 1 to x squared. Okay, so the derivative there is going to be 6. We probably want to rearrange it this way. Like that. Okay, so that's the chain rule. This is another way of writing the chain rule. And this other way would be like if you had y equals e to the cosine x, for example. Okay, and then so in this case, the u, okay, so here the u is outer, and wait a minute. Never mind. That's confused. This one's confusing. Let's not do that one on this one. Okay, so dy du. So you rethink. So u is actually the inner function. I'm sorry. So u is the inner function, and they don't talk about an outer function here. So the u in this case would be cosine x. So you think of this as also being e to the u. Okay. You think of this as being e to the u. Okay, so dy dx is going to be the derivative of y with respect to u. So that's just going to be e to the cosine x, e to the u. The derivative with respect to u is e to the u. But you put the u back in, you put the cosine x back in for the u. And then you multiply by the derivative of the cosine with respect to x. The derivative of cosine is negative sine. Okay, so that's going to be negative sine x e to the cosine x. Okay, that's an example of doing it that way. And also, one advantage of this notation, to remember it, is that you can kind of think it's not really multiplication, but you can kind of think of it as multiplication and just think, oh, these du's are going to cancel, and we get dy dx. Okay. Another way to think of the chain rule is, okay, so you have a y. So here we have a y at the top, then y is a function of u, and then u is a function of x. And so if you move x a little bit, then that's going to affect u, and then so however x varies, that affects u, which in turn affects y. Okay. Okay. So y. So it's kind of like a chain up there. Here's the power rule combined with the chain rule. Okay, so that's where you have something like, let me do it in a different color. Okay, so that's where you have something like some expression, maybe x squared plus 3 raised to the, let's raise it to the, we just raise it to a power, right? So we can just raise it to the 5th power, is what they mean. Okay, so this would be this raised to a power. Okay, so in this case, the outer function is actually x to the 5th. And the inner function is actually x squared plus 3. So it's a matter of recognizing that. Okay, so applying the power rule, applying the chain rule, this 5 is going to come down. So the derivative of x to the 5th is 5 times x to the 4th. Okay, so that's just like that. Okay, so all this stays the same. Now you multiply by this other part right here, which the g is the middle. You multiply by the derivative of that, which is 2x. The derivative of x squared plus 3 is 2x. Okay, so that's going to give you the 5 and the 2 multiplied to be 10. And then we rearrange it this way. Okay, so that's going to be the derivative there. So that's using the power rule combined with the chain rule. Okay, let's get into the exercises. So number 1, write the composition function in the form f of g of x. Identify the inner function and the outer function. Okay, so the inner function is going to be 5 times the square root of x. But we probably want to write it as 5. Well, we're not going to take derivatives, so let's just do it like that. So that's the inner function. The outer function is just e to the x. Or they want to write it in terms of u, so e to the u. So this 5 root x is all u. Okay, so e to the u, comma, 5 root x would be the answer there. And then to find the derivative, okay, so remember it's the derivative of the outer function, which is just itself, but applied at the outer function, applied at the inner function, I'm sorry. Okay, so that's dy du. That's the derivative with respect to u, which is just this. And then you put the u back in. You put that 5 root x back in for the u. Times the derivative of this part. So pull the 1/2 down, that's 5/2, x to the negative 1/2. And x to the negative 1/2 is the same as 1 over x to the 1/2, which is the square root of x. So that should work here. For the answer for that one. Okay, any questions at this point? This might be really confusing, but it's something you've got to learn. Otherwise, you will not do well in this class. Okay, so find the derivative of this function. And so first thing here, you notice that the outer function is the square root of u, or u to the 1/2. And then also, we can write this as 5x plus 9 to the 1/2. Maybe the easiest way. And then the inner function is 5x plus 9. But maybe the easiest way is to use the power rule with the chain rule. So I'm taking the derivative. You treat this as just a u to the 1/2. You're taking the derivative, that's 1/2 u to the minus 1/2. So pull the 1/2 down, and then 5x plus 9 to the minus 1/2. Okay, so maybe you can think in your mind that this is going to be 1/2 u to the minus 1/2, and then put this u back in. Okay, then you have to multiply by the derivative of the inside, which is 5. The derivative of 5x plus 9 is 5. Okay, so that's where that comes from. And then we can rearrange things. So that's 5 halves times 5x plus 9 to the negative 1/2. That answer should, that form should work. You could also put it like 5 over 2 times the square root of 5x plus 9. That works too. Okay, let's take a look at number 3. We have f of theta equals cosine of theta squared. So theta, just treat that like an x. And cosine is the outer, theta squared is the inner. Okay, so if you just had cosine u, the derivative of cosine u would be negative sine u. Okay, but instead of u, we'll put theta squared in. And then multiply by the derivative of the inside, which is 2 theta. Okay, so you're going to get negative 2 theta sine of theta squared. Okay, number 4. Find the derivative of this function. Oops, I forgot to put in. Oh, this parenthesis here is up here somehow. Okay, it's supposed to be like that. Okay, so here, what we have here is we actually have a series of functions. So it's probably best to think of it this way. When you see these squares on the sines and cosines right here, or like a cube or something, then that is kind of confusing. So instead of writing it there, it's sometimes best to, when you're taking the derivative, it might be best to help you think better about it, to write these squares out here. So instead of writing the square right there, then you write it out here. And then you can see that that's clearly, it's clearly it's clearly the square is the outer function. Okay, so the squaring is the outer function. But then the sign is that you have like a bunch of, you have like a series, you don't have just have an inner and an outer. You've got this outermost, and then you have the sign is the next outermost, and then you have the E is the next outermost, and then this square is the next, and then you have sine t as the innermost function. So you've got like several layers here, but it doesn't really matter because, well, it does matter, but here's how you would do. You take the, I'll do these by layers, okay? Okay, so we'll start with the outermost layer right here, just raising it to the square. Okay, so that one comes out 2 multiplied by this. And now when I do this, I can rewrite the sign right there if I want. Okay, so that's a 2 comes down. This is like all of this is like u squared, and the derivative is 2u. So 2 times that. Okay, so bring the 2 down, reduce this by 1 to 1. Okay, now next layer is we need to multiply by the derivative of the inner function. But this inner function is also a composition. So think of this as sine of u now. So the derivative of that is cosine of u, or it's cosine of e to the sine squared t, times the derivative of this the inner function here. Okay, and so the sine is the outer here in this case. So the derivative of sine is cosine of this exact same thing. Then we multiply by the derivative of this. The outer function here of just this one is e to the u. So we are e. So the derivative of e to the u is just e to the u. So we write that right there. And then we multiply by the derivative of this inner function, which is sine squared. But sine squared is this. So the outer function here is this square. So 2 times, so this is u squared, so the derivative is 2u. Okay, and then times the derivative of sine, which is cosine. Okay, so this is applying the chain rule it's like several times, because what happened is this is the original inner function has an inner and outer function, and the next one does, and so on down all the way down until you get to this sine t, and that's the innermost function, and so its derivative is cosine t. Okay, so then if you collect everything together, so you've got a 2 there and you have a 2 there, so that's going to be 4. And then let's put the sine t and the cosine t out front. And then let's put this e to the sine squared t. And then let's put this one. And then we'll put this one right here. Okay, so that was quite painful, but not quite as painful as this next exercise, number 5. And again, like I said, if you have any questions, just let me know. So I'm going to go ahead and rewrite this, because this sign, like I said, the square on the sign is better if you put it right there. Okay, so first of all, you have the outermost function is, all this is raised to the 4th power. So the outermost function is u to the 4th. Then you have a u right here. Okay, so the derivative is going to be 4 times u to the 3rd power. Okay, so we'll to the 3rd power. Okay, then now we're going to multiply with the inner function. This is the inner function right here. And so its derivative is going to be 1 So derivative of this is just 1 plus, okay, now here, now here we have, this is like, all this is like u to the 7th. Okay, so the derivative of this is going to be 7 times u to the 6th power. Okay, but then it's going to be multiplied by the derivative of this inside part right here. But they're just multiplying just this part. You're not multiplying the 1 by that. Okay, so the derivative of this is going to be 1 plus, and then here, the sine x is kind of like u squared, or the sine x squared is like u squared. So that's going to be multiplied by, so that's going to be, the derivative of u squared is 2u. So bring the 2 down, and then multiply by cosine x. Okay, so the derivative of sine is cosine, not cosine n. Okay, so this is quite painful. But, so here we go. So you just have this 4 out here, so I'll have that 4 out by itself. Then this is pretty much all contained here. So this is going to be x plus sine, and we'll put the squares back right there. The 3rd power. Let me think. You should use parentheses. Okay, but these parentheses go with each other. Okay, then multiply by all this. 1 plus 7 x plus sine squared x to the 6th. And then just this term is multiplied by this. And parentheses there. Okay, so that should work. I think that's about the most painful exercise. Any questions on any of this? Okay, let's go ahead and do number 6. So here we're supposed to find all points on the graph or the function at which the tangent line is horizontal. Okay, so the tangent line being horizontal, that means that the derivative is 0. So we're going to take the derivative. Okay, the derivative of this. And then also, again, this sine x, you think of it this way. Okay, so derivative of this is just 2 cosine x. Notice I didn't even use the chain rule right there, but this one requires using the chain rule. Okay, plus 2. Okay, so this is like u squared, so derivative is 2u, times the derivative of sine x, which is cosine x. And do you want to know where that is going to be 0? Okay. And so that's, we can factor cosine x out, or actually we can factor 2 cosine x out, and we're left with 1 plus sine x, and that's equal to 0. So we have cosine x being 0, or this could be 0, which means that sine x is -1. Okay, now this happens when x is 3 pi over 2 plus any multiple of 2 pi, right? Okay, so sine x being -1 would be where you have an angle down here. So negative pi over 2 would work. This is 3 pi over 2 here. But you go around once and then back to 3 pi over 2, or you go backwards this way to negative and then back to negative pi over 2. So, but anyways, any multiple, so you put an n there, any multiple of 2 pi, either positive or negative, or and it could be a positive integer, negative integer, or 0. So any integer, n is any integer, was going to make the sine x equal to -1. Now, when sine is -1, then cosine is 0. Okay, so these points also satisfy this. But points that don't satisfy this one, but don't satisfy that one, are pi over 2 plus 2 pi n. Okay, so this one would be the points up here. And see, there's pi over 2. And the cosine is 0 right there. But then you could go around once or whatever. So any multiple of 2 pi n, of 2 pi. Okay, so these are just the x values. So we also need to find what happens when, what is the function at one of these points. So pi over 2 plus 2 pi n. Well, that's just going to be f at 2 pi, at pi over 2, I'm sorry. And you plug it into the original function. This is 2 plus 1. That's going to be 3. Okay, f of 3 pi over 2 plus 2 pi n. That's just going to be f of 3 pi over 2. And here, this is going to be -1 or -2. Actually, I should write this way. Sine is -1, so that's -1. And then here is -1 squared. So that's all going to be, that all works out to be -1. Okay. So this one gives you is pi over 2 plus 2 pi n, comma 3. And this one is 3 pi over 2 plus 2 pi n, comma -1. Okay, so these are going to be the two answers. Okay, but this one right here is actually goes first. It's the smaller y value, because it's -1, which is smaller than 3. And this is the larger y value. Okay, so just put it in like that, and that should work. Okay, let's go back. Let's think about again. And let's just like look at the basic formula from the beginning, which was that if you have f of x equals little f of g of x, then the derivative is going to be the derivative of the outer function evaluated at the inner function times the derivative of the inner function. Okay, so number 7, the differentiable functions f and g are defined for all known numbers x. Values of f, f prime, g, and g prime for various values of x are given in the table. And so h of x is equal to f of g of x. Okay, so that's what that's telling us, is that h prime of x It's just because if it's f of g of x, then it's just this right here is f prime of g of x times g prime of x. Now they're asking for h prime of 1. So you substitute a 1 in for x. Okay, so that x got replaced with a 1, and that x got replaced with a 1. And there's no other x's. Well, that one, because that one got replaced with a 1. Okay. Now, you look at the table. G of 1. Here's g. G of 1 is 2. Okay, so g of 1 is 2. And then g prime of 1 is 6. And then f prime of 2 is 5. So that's going to be 30. Okay, now we have the second part. Capital H is g of f of x. So this is switched, the order switched around. It's still the same, it's the same formula. You can still apply the same formula. G is the outer function and f is the inner function. So it's the derivative of the outer evaluated at the inner times the derivative of the inner function. And then wants to find h prime of 2. Okay, so we already know from here that f prime of 2 is 5. So this is going to be 5. Now f of 2 is, f of 2 is right here. So f of 2 is 1. And then g prime of 1, we already saw that that's 6 right here. Okay, so it's also going to be 30. It's just a